Next technique for medium access that we'll be discussing is classical aloha. Basically, classical aloha is time division multiplexing without imposing any control on accessing the medium. That is, that is anybody, if they want to access the medium, they can just like that access the medium without sensing whether the carrier is free or not, without following any protocols. They just access the medium. That's it. So this technique was invented in University of Hawaii, and it is used in a network which is called as Aloha Net. So here the medium is not coordinated, and also there was no effort taken to resolve contention. So so basically this is a random access scheme where there is no central arbiter for coordinating among multiple stations. So when there is a collision, if two or more station access the medium at the same time, obviously there will be collision. If there is a collision, that will be dealt by the higher layers. And uh, for simple aloha, so this protocol is also called as simple aloha. Classical aloha is otherwise called as simple aloha. So it is good as long as the load is good. For example, if you are applying this protocol in an environment where rarely somebody communicates, then this protocol is fine because you need not check that the medium is free or not. Just like that, you can communicate because most of the time the medium will be free. Rarely a collision may occur. The throughput achieved with this protocol is 18 percentage. This is the maximum throughput that can be achieved through classical aloha. So so this is what classical aloha is. So basically classical aloha is there is a channel and any user can use the channel at any time without checking for anything. They need not check whether the medium is free or not, can be accessed now or not. No, they can just like that they can access, and there is no arbiter here to coordinate among multiple stations. Anybody can randomly access the channel. So obviously there is a possibility for collision. If collision occurs, that will be left to the higher layers. The higher layers has to deal with the collision. Okay. So this network was originally introduced in the University of Hawaii, and it is used in a network which is called as Aloha Net. So it is not so simple. Aloha, it is fine as long as the load in the network is comparatively less. So if the load is less, and if any user communicates with other user, then this protocol, classical Aloha or simple Aloha, can be used because most of the time the channel will be free and somebody can randomly just use the channel, and the probability of collision will be very less. The maximum throughput that is achieved through this particular classical aloha technique uh, or simple aloha technique is up to 18 percentage. That is, it cannot produce an throughput which is more than 18 percentage. Okay, so this is about classical aloha, and it was originally uh, proposed by um, in the University of Hawaii, and 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 this is how the concept of classical aloha works. So this diagram shows how exactly classical aloha works. This is the medium here. So you can see uh, the shared medium. So this is the shared medium, and sender A, whenever he wants, he is communicating. Sender B, whenever he wants, he is communicating. And sender C, whenever he wants, he is communicating. They are not at all checking whether the channel is free or not. Can we communicate? No, nothing. They just communicates. So you can see these are the points there were collisions, because here all the three senders were sending at the same time. Here A and B were sending at the same time. Okay, so this leads to collision, and collision is left to be dealt by the higher layers. So basically this is how the classical aloha or simple aloha protocol works. Okay, So the next algorithm that we'll be discussing is slotted aloha. Slotted aloha is the first improvement or first refinement over classical aloha. Here time slots are introduced. If you see the classical aloha diagram before that, there is no time slots. Anybody can send at any time. There is no time. Time is not divided into slots. Whereas in slotted aloha, the first improvement, first refinement done was the introduction of time slot. So there will be some time slot, and he if anybody wants to transmit or communicate any information, they can transmit only at the beginning of a time slot. If any user want to communicate something, they can transmit the information only at the beginning of the time slot. They cannot just like that transmit at any time. If any user want to communicate, that communication only happens at the beginning of the time slot. So this introduces some level of access coordination. This introduces some level of access coordination. We cannot say the access is fully coordinated. To certain degree, it is it introduces coordination. Okay, the throughput achieved with this is 36 percentage. So if you compare the throughput with classical aloha, with the classical aloha the throughput achieved is 18 percentage, but here it is 36 percentage. So it is so the introduction of slots. So the only improvement when compared with classical aloha and slotted aloha is the addition of time slot, and another condition that the user can only transmit data at the beginning of the time slot. Just by introducing these two features, the throughput is getting doubled. So that is something interesting. And again, slotted aloha also works well with light load. It cannot work well if the load is heavy, and also it cannot guarantee features like maximum delay or minimum throughput. Such hard transmission guarantees they cannot give. They cannot give these type of guarantees like maximum delay or minimum throughput. These are not guaranteed by slotted aloha. Um, so basically, uh, even even new mobile communication systems like UMTS use slotted aloha. Universal Mobile Telecommunication Service, they rely on slotted aloha for medium access for initial connection setup. Okay, so it is not that slotted aloha is not used now; it is getting used even by new mobile communication systems like UMTS. They are using it for initial communication setup that is done by using slotted aloha. So this is how slotted aloha works. Okay. The next kind of medium access technique that we'll be discussing is carrier sense multiple access. But before that, let us go through this diagram which explains the concept of slotted aloha. So here you can see the time is divided into slots. This is the only difference when compared with the classical aloha. The time slots were introduced. So this is one time slot, this is another time slot. Okay, so like that we are dividing time into multiple slots, and if whenever a sender wants to communicate, he can communicate only at the beginning of the slot. It is not that someone can start a transmission at somewhere here. No, that is not possible. Anybody wants, you can start at the beginning of the slot. If you miss the beginning of the slot, then you have to wait for the next beginning slot. Okay, so at any beginning of the slot they can start the transmission. Okay, so that is the overall concept. So comparatively, when compared with the classical aloha, it improves the throughput. In classical aloha, the throughput maximum throughput achievable is 18 percentage, whereas with slotted aloha, the maximum throughput achievable is 36 percentage. So here also we can see some places there are some collisions. So these are the places where there are collision. Okay, here all the three are trying to communicate. Here two users are trying to communicate. So this is the basic working methodology of slotted aloha. So the next technique that we'll be discussing is CSMA. So CSMA is carrier sense multiple access. So here the carrier sensing feature is also added. That is, here the logic says that before a user want to communicate, or before a mobile station wants to communicate, it should sense the carrier. If the carrier is uh, if the carrier is idle, it can access uh, the channel. Okay, if the carrier is idle, it will access the channel, so it decreases the probability of collision. So here also you cannot say that there is no collision. So if the carrier is idle, that doesn't mean that there is no pollution. No, two mobile stations may sense the carrier at the same time, and they may sense it to be idle, and they may communicate, and because of that, there may be collision. Okay, but still, it decreases the probability of uh, collision to a larger extent. Okay, but even CSMA, that is, even if you include the carrier sense feature, it cannot solve the hidden terminal problem. It cannot solve the hidden terminal problem. So as we already discussed, still there will be issues with hidden terminal and exposed terminal problems. This is a basic scheme which is used in some wireless, in most of the wireless lands. Okay. There are different versions of CSMA available. So let us try to understand the various versions of CSMA. The first version of CSMA is called as non-persistent CSMA. This is a very basic version. What it says in the sense, sends the carrier and send the information if the medium is idle. Sends the carrier and send the data if the medium is idle. If the medium is busy, then wait for a random amount of time and again sends the carrier. Okay, so this cycle continues. It sends the carrier. If the medium is free, it can transmit data. If the medium is not free, then wait for a random amount of time, then again sends the carrier. And if the medium is free, send the data, otherwise wait for a random amount of time. Like that, the non-persistent CSMA works. The next version of CSMA is P persistent CSMA. So P persistent CSMA, what it says in the sense, sends the medium. If the medium is free, then transmit with the probability of P. If the medium is free, then transmit with the probability of P. Why we say that? If the medium is free, it can access. No. Why should we say that medium is free? Then you should transmit only with the probability of P. Because as we already discussed, medium is free, but I am not the only user who is sensing the medium at this time. Maybe some other mobile station may be also sensing the carrier, the channel at the same time, and they may be also thinking that the medium is free, and they may be also sending the data. So both these data may collide with each other, and that may result in a collision. Okay, to avoid that, the mobile station senses the carrier, and even though if the carrier is free, it will not always transmit. It will only transmit with the probability of P, and it will wait with the probability of 1 minus P for the next slot. And it will wait with the probability of 1 minus P for the next slot. Okay. So this is how P persistent CSMA works. So P can be any value, right? P can be any value. If P is zero point 0.5, if P is zero point 0.5, then 50% of the time, if the carrier is free, it will transmit. Other 50% of the time, it will differ for the next slot. Okay. Whereas in one persistent CSMA, if p value is 1, then what will happen? Whenever the mobile station senses the carrier, if the carrier is free, it will just transmit. It will just transmit. But now more than one mobile nodes may be sensing the same information, and it may result in a collision. So all stations wishing to transmit access the medium at the same time as soon as it becomes idle. So this will cause many collisions if many stations send send the data at the same time, and they will block each other. Okay, and they will block each other. And if the load is high, then what happens in the sense, always some or other stations will be waiting for the carrier. If the load is high, always some or other stations will be waiting for the carrier. And whenever the carrier is free, everybody will be competing for the carrier, and everybody will be competing for the carrier. So here we have to introduce some fairness for the stations which are waiting for a longer time. Here we should introduce some fairness for the stations which are waiting for a longer period of time, because they are waiting for a longer period of time, so they should be given the carrier in preference to the stations which is waiting for a shorter period of time. Okay, how could we ensure that? How could we ensure that? For this, for this, CSMA has introduced some back-off schemes. For this, CSMA has introduced some back-off schemes. So basically, back-off schemes were introduced to ensure that there is some fairness among competition stations, such a way that the station who is waiting for a longer period of time will be given access earlier. Will be given access earlier. Okay. So that is done by using back of algorithms. It is done by using back of algorithm. Okay. So one such back off technique is called as CSMA CA. One such back off technique is called as CSMA CA. So CSMA stands for carrier sense multiple access, and CA stands for collision avoidance. Collision avoidance. Okay. So here sensing the carrier is combined with the back-off scheme in case of a busy medium to achieve some fairness among competitive stations. Okay. So, so this is how CSMA works. So what CSMA does in the sense, it basically senses the carrier and only it will transmit if the carrier is idle. If the carrier is busy, then it will wait. So there are different versions of CSMA available. So we have discussed non-persistent CSMA. Non-persistent CSMA, it will not wait, it will just sense the carrier, and whenever it found the carrier is idle, it will just access the carrier. Whereas P-persistent CSMA, it will sense whether the carrier is idle or not. If the carrier is idle, then it will transmit with the probability of P. It will transmit with the probability of P. And one persistent CSMA, it will so this is, sorry, here there is a spelling mistake, this is CSMA. Okay, it's not CSAM, this is CSMA. So one persistent CSMA will sense the carrier. If the carrier is idle, it will always transmit. So now if more users were competing for the carrier, then all the data packets will collide with each other. That is the problem that will be created with one persistent CSMA. So it is not advisable to go for one persistent CSMA. Depending on the load, this factor should be decided. Okay, this may vary with network to network. Depending on the node, this should be ideally some correct value should be chosen here. Okay, and also to ensure there is fairness among competition stations, such a way that the user who is waiting for a longer period of time will get the channel earlier. So some techniques were introduced, and one of the technique is called as CSMA CA. It stands for carrier sense multiple access with collision avoidance. So CSMA CA, what it does in the sense, along with sensing the carrier, it also introduces some back-off schemes. It also introduced some back-off schemes. So these back-off schemes, basically these schemes are introduced. We'll not be discussing how these back-off schemes works, but just understand that these schemes will ensure that the user who is waiting for the carrier for a longer period of time will get the channel earlier in when compared with the user who is waiting for a shorter period of time. Okay. So this is how the CSMA model works. The next uh, concept for medium access, okay, we'll be discussing is DAMA, demand assigned multiple access. Demand assigned multiple access. Okay. So this is basically a reservation scheme. This is basically a reservation scheme. Like how we reserve tickets in for hotel or for movies. Okay, for such or for any watching any competition like cricket match, anything. First you have to reserve your ticket. Okay, once you reserve, your channel is fixed and then you can use the channel. So this is such kind of reservation technique. Okay, so whenever a station want to use the channel in the future, earlier itself he should reserve the channel, that so and so time I want to use the channel for this much time, like that he should reserve it and then he will use it. So this is basically a reservation scheme which increases the uh, cha- which increases the efficiency up to 80 percentage. Okay, that is, it increases the throughput up to 80 percentage. So the sender will reserve the future time slot. Okay. And sending within this reserved time slot is possible without collision. So as he is already reserving, as he is reserving his time slot for the future, so here there is no issue of collision. Okay. So here the uh, entire communication will be divided into two parts. Two parts. One is called as one is called as reservation phase, and the other one is called as the communication phase. Okay, the entire communication duration will be divided into two phases. One is the reservation phase, the other one is the actual communication phase. So during the reservation phase, the sender will the the particular mobile station will just try to reserve its communication. During the reservation phase, the each of the sender will just try to reserve their communication, and once it is reserved, they can be used for the transmission. Once it is reserved, it can be used for the transmission. Yeah. So in this scheme, there will be a reservation period followed by the transmission period. During the reservation period, stations will reserve the future slots for transmission. Okay. Collision can happen in the reservation period, but there will not be any collision for in the transmission period. Okay. So this scheme produces higher throughput as there is less collision. So, so DAMA is also called as reservation aloha. So DAMA is also called as reservation aloha. It is also basically an improvement of aloha technique. So it is called as reservation aloha. Basically, this technique is used in satellite system. Basically, this technique is used in the satellite system, and it follows an explicit reservation scheme. It follows an explicit reservation scheme. So there are two phases. One is the reservation or contention phase, and the other one is the actual transmission phase. So during the reservation phase, different stations will try to reserve their future communication. Okay, there can be collision during the reservation phase, but there will not be any collision in the actual transmission phase. If the reservation is successful, a time slot in the future is reserved and no other station will be allowed to transmit during that particular time slot. Okay, so basically this is used for satellite communication. So if the mobile stations want to communicate with the satellite, then during the contention phase they should reserve like which time slot they want to communicate, and that will be communicated to the satellite. And once the satellite got that information, finally the satellite will send a complete list to the ground station, like these are the time at which the different stations will be communicating. And so all other station will understand like which time is allotted for them and which time is for some other stations. Okay, so this scheme is also called as what you call explicit reservation technique, but it also create some delays. Let us understand how this technique works. So as already mentioned, it has basically two modes. So in the during the reservation mode, it follows Aloha protocol, the normal Aloha. Okay, during the reservation mode, it follows Aloha protocol. That is, Aloha means what? Anybody can access the channel. So during reservation alone, it follows Aloha. It means anybody can access the channel for reserving. So there is no control or coordination is done during reservation. So whoever come first, they will get the slot. And if multiple users are trying to access the slot at the same time, it will result in collision. Okay. So once reserved, the data will be transmitted successfully in the reserved slot. In the reserved slot, there is no collision. During reservation, there can be collision. Once it is reserved for actual transmission, there is no collision. Okay. But one thing is important here. Once the satellite sends the list, like these are the typical times during which various stations will communicate with the satellite. All the other stations should obey that list. Okay, all the other stations should obey that list. All stations should synchronize from time to time, so they should know like which time the others are going to communicate, so that we can ensure that there is no collision. Okay? So this is how basically this diagram shows like how DAMA works. So here you can see this is a reservation phase or a contention phase. Okay, and this is the reserved phase or the actual transmission phase. Okay, so every reservation phase will be followed by a transmission phase. So this is the reservation phase, and this is the reserved phase. So like that, every reservation phase will follow a reserved phase. Okay, so these are the various slots. Okay, so if somebody want to use this slot, then he should reserve here. I'm going to use that slot like that. Okay, if somebody want to use this slot, then he should reserve here. I want to use this slot like that. Okay, if somebody want to use this slot like that, they should use reserve. So here you can see nobody want to use the first slot, so first slot is empty. Somebody has some user X has reserved the second slot, some user Y has reserved the third slot, again X has reserved the fourth slot because the color is same. Again the next slot is empty, nobody has reserved this. Okay, so here you can see the first slot is reserved by X, nobody has reserved the second slot, again third slot is reserved by X, but fourth slot there is a collision. You can see there is a collision here when they are during reservation, not the actual transmission. Two persons want to use the fourth slot, so they tried to reserve at the same time, and that resulted in the collision. Okay, so because of that it is empty, because of that it is empty. So here if you see, first slot is registered by some user, say Z, second slot is also registered by the same user Z, the third slot there is a collision, there is a collision. Two users were trying to access at the same time, X and somebody else. So here there is a collision. Fourth slot is reserved for X. Fifth slot also there is a collision. Okay. So here there is a here. So as there is a collision during the reservation phase, this is during the actual communication phase. This slot is empty. Okay. So this slot is empty, right? So during reservation, it follows Aloha scheme. Okay, so there is no coordination like who should reserve when. No, anybody can try, right? And here if you see, only the first slot is reserved by X, all other slots are currently empty. Okay, so this is how the basically the DAMA, demand assign multiple access technique, works, right? So the next algorithm that we'll be discussing is PRMA. So PRMA stands for Packet Reservation Multiple Access. PRMA stands for Packet Reservation Multiple Access. So this is also one reservation scheme. This is also a reservation scheme, but this is an implicit reservation technique. Whereas DAMA, demand assign multiple access, is an explicit reservation technique. That is, you have to explicitly reserve, like how we are reserving for hotel, or how you are reserving for a cricket match. Like that, explicitly you have to reserve in DAMA, but that is not required in PRMA. It is an implicit reservation technique. Okay, so here slots will be reserved implicitly according to a scheme. According to a scheme. Okay. So here set of slots will form a frame. Some number of slots, a certain number of slots will form a frame, and the frames will be repeated. The frames will be repeated. Stations can compete for empty slots. Stations can compete for empty slots using slotted aloha principle. That is, they can compete during the beginning of that particular slot. It is a set of slots will form a frame, and these frames will be repeated. Different mobile stations can compete for empty slots according to the principle which is called as slotted aloha. Slotted aloha we have discussed how it works, we know. Okay. Once a station reserves a slot successfully, this slot is automatically assigned for that station in the following frames as long as the station has data to send. So once, so say once, if I reserve slot 6 for me, then it means that as long as I don't give up, I'll be keep using slot 6. Okay, it doesn't mean that every time I should try for the slot. Okay, whereas in DAMA, every time again you should try for that particular slot. Okay, but here that is not the case. Once if you get the slot, you can use it as long as you want, and finally whenever you don't want, you can release that slot. Okay, so the competition for the slots begin as long as the slot was empty. Okay, so let us try to understand with a particular example. So here you can see there were totally 8 slots. 8 slots forms a frame. Here there are 8 slots, and these 8 slots forms a frame. So this communication also basically used in satellite communication. Okay, so initially if you see, all the first 6 slots are occupied. So so initially this is the information that was sent by the satellite to the mobile station. Mobile station satellite is sending this information to all mobile stations. So this information, what it says in the sense, first slot is occupied by A, second slot is occupied by C, third slot is occupied by D, fourth is occupied by A, fifth is occupied by B, sixth is occupied by A, seventh is an empty slot. Seventh is an empty slot. Anybody can compete for this. Seventh is an empty slot. Anybody can compete for this. And eighth slot is F. So this information, the satellite is passing to the, what do you call, passing to all the ground, all the mobile stations. Now anybody can compete for the seventh slot. Okay, now what happened in the sense, this information was passed, say at time t naught, at time t naught, at time t1, at time t1, this is time t1, at time t1, let us assume that more than one user is competing for this slot. Not one user, more than one user is competing for this slot, that is, which is an empty slot previously, which was sent by the satellite. So there is a collision. So there is a collision because two users were trying to compete for the same slot. So as a result, there is a collision, and nobody was given that slot. Nobody was given that slot. Again at time t2, again at time t2, the satellite is sending this information, that is, which is same as the information that was sent at time t naught, which says that first slot is occupied by A, second slot by C, third slot by D, fourth slot by A, fifth slot by B, sixth slot by A, seventh slot is again free, and eighth slot is occupied by F. So this information again means the same thing, that seventh slot is still free. Anybody can compete for seventh slot. Okay. But this time what happens in the sense, nobody competed for seventh slot. Nobody at time t3, nobody competed for seventh slot, and also it so happened that, D has given up slot 3 and F has given up slot 8. D has given up slot 3 and F has given up slot 8. So two more empty slots created. Okay. So at time t4, the satellite is sending this information that first slot is occupied by A, second is occupied by C, third is an empty slot, third is an empty slot, third is an empty slot, and fourth slot is occupied by A, fifth slot is occupied by B, sixth slot is occupied by A, and seventh slot is occupied by F. Okay, so here, so previously at time t3, what happened in the sense, it is not that nobody has competed for 7 slot. F has only F has competed for 7 slot. Only F has competed for 7 slot, and F got the 7th slot. F got the 7th slot, but D has given up slot 3, and F has given up slot 8. Okay, so this information now satellite is passing, because only satellite knows who was given the slot F, who was given the slot 7. Okay, so this information is now passed to the mobile stations. So which means that now slot 3 and slot 8 are empty. Anybody can compete for that. Anybody can compete for that. Okay. Now again at time t5, what happens in the sense, more than two users were competing for the time the slot 3, and because of that there is a collision. So at time t6 again the satellite says that time slot A is first is occupied by A, 2, 3 and 4 are empty, and 5, 6, 7 and 8 are occupied by B, A, F and D respectively. Like that it is passing an information. So here one more thing you should understand, at time slot 5 there is a collision, uh, at time 5 there is a collision for the slot 3. There is a collision for slot 3. The collision occurred for slot 3, but D has successfully received slot 8, but D has successfully contended for slot 8. It means only D has tried for slot 8. Nobody else has tried for slot 8. So D has tried, and D has got it. So that is what this says. So because satellite is passing saying that the 8th slot was given to D, it means at T5, once the satellite passed this information at T4, so anybody can try for all these slots, right? Anybody can try for all these slots. uh, Okay, anybody can try for these slots, uh, but only, we at that time, what are the free slots? 3 and 8. Anybody can try for 3 and 8, but two users tried for 3, so they resulted in a collision. But only one user D has tried for the time slot 8, and it received it. Okay, so that is what this particular thing says, right? Okay, so now at time 6, satellite is sending this information. That is, A is first slot is occupied by A, second 3 and fourth slots are empty. Fifth, sixth, seventh, and eighth slots are occupied by B, A, F, and D respectively. It means that anybody can compete for second, third, and fourth slots. So now what happens? C has competed for second slot, E has competed for third slot, and also E has competed for fourth slot, and they all got it. There is no collision. Nobody else has tried for these slots. So again, satellite is passing this information stating that all slots are occupied by this station. First slot by A, second by C, third and fourth by E, fifth by B, sixth by A, seventh by F, and eighth by D. Okay. So this technique is called as implicit, reservation, or it is also called as PRMA, packet reservation multiple access technique. Okay. So this is how the concept of packet reservation multiple access technique works. Okay. So 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 that's it about this particular session. So basically, what are the things we have discussed in this session? So we started with motivation for specialized Mac. That is, we understand here, why should we go for a special Mac for wireless network? Why can't we use the existing Mac which is already available in the wired network, that is 802.3? So the existing Mac, it follows CSMA CD protocol. Carrier sends multiple access with collision detection. But that cannot be used in a wireless network because it will create issues like hidden and exposed terminal problem, near and far terminal problems. Okay, to avoid these kind of problems, we need a specialized Mac. So that we have understood initially. Then we have discussed various medium access techniques like SDMA, FDMA, and TDMA. Okay. So SDMA, in the sense, it is identifying the optimal tower for a particular mobile user. SDMA will not be applied isolatedly. That is, you will not apply only SDMA. SDMA will be combined with FDMA or TDMA depending on the requirement. And then we have discussed FDMA. Here the frequency will be divided into here the entire channel will be divided into multiple frequencies, and each user will be given a different frequency slot. And we have discussed like fixed frequency or changing frequencies. With fixed frequencies, the frequency will be permanently allotted for a particular user, but that is not advisable for mobile communication. That is fine with the radio communication, because radios will be keep on transmitting, so one frequency is fine for them, but that is not the case with mobile communication. Here the frequency will here the user communicates depending on his requirement, so user will not communicate always, so it is not advisable to allocate one frequency for a particular user. Then it means we are not using the bandwidth efficiently. So so the frequency should change at a different point of time. At different point of time, the user should be given different frequencies. At different point of time, the user should be using different frequencies. And if the user is using different frequencies at different point of time, then the receiver should also know. If the sender is using different frequency at different point of time, the receiver should also know at what frequency the sender is communicating, so that the sender and the receiver can be coordinated. So that is called as hopping sequence. That is called as hopping sequence. So the hopping pattern between the sender and the receiver should be synchronized. Okay. And also we have discussed about uplink and downlink. The communication from the base station to the mobile station is called as uplink, and uplink frequencies will be different and downlink frequencies will be different. The communication uh, the communication from the base station to the mobile station is called as downlink, and downlink will use a different set of frequencies, and uplink will use a different set of frequencies. Generally each frequency's bandwidth will be 200 kilohertz. And also we have discussed like how to map an uplink frequency with a downlink frequency. Generally, the uplink frequencies and downlink frequencies are separated by 45 megahertz. So you have to just add or subtract 45 megahertz to convert uplink to downlink or downlink to uplink. Okay, so that is what we have discussed under FDMA. And then we have discussed TDMA, time division multiple access. So in time division multiple access is more flexible when compared with frequency division multiple access. Because with frequency division multiple access, there are many frequencies, and the mobile stations or the user has to tune themselves to that particular frequencies depending on the various factors, and these frequencies are also not fixed. It is going to change, and the sender and the receiver should be synchronized with the hopping pattern, but all these are not required in case of TDMA, because with respect to TDMA, there is only one frequency. There is only one frequency, and the medium is shared in terms of time. Okay, that is different time slots will be given for different users. Different time slots will be given for different users. Okay, so how it works, in the sense we have discussed the working of that with an example where there are 12 slots for the uplink, that is for communication from the mobile station to base station, and another 12 different slots for downlink, that is for communication from the base station to the mobile station. Okay, so each slot will be so it means that it means maximum 12 mobile stations can communicate with the base station. Okay, and each slot will be given a particular amount of time, and during that time alone they can access the channel. So we have discussed a practical example, like where TDMA was implemented. So one such example, what we have discussed is DECT. DECT uses TDM, time division multiple access, where the entire pattern is repeated for 10 milliseconds, and each slot has a duration of 417 microsecond. Okay, so this is fine for fixed access patterns. This is fine for fixed access patterns, but if the data is bursty, the data is bursty. That is, if you are if it is a voice data, that kind of communication is fine. It will do. But if you are communicating any browsing data, say if the user is browsing a web page, then most of the time he will be idle. He will be reading some content from the website, and suddenly he may click some link. Then a lot of information will be transmitted. So that is called as bursty data. So in case of bursty data, this kind of communication is not advisable. So that is what we have discussed under TDMA and fixed TDM. And the next thing what we have discussed is classical aloha. So classical aloha is the very simplest form of aloha, or it is otherwise also called as simple aloha. So in classical aloha, if any user want to access the channel, they just access the channel. They don't check anything. There is no coordination. There is no arbiter. The user will just access the channel just like that. So as a result, it may lead to collision. It may lead to collision, but the protocol says that if at all there is a collision, the collision will be dealt by the higher layers, and the maximum throughput that is achievable through classical aloha or simple aloha is up to 18 percentage. Is up to 18 percentage, and this technique was originally introduced in University of Hawaii, and it was used in a network, and that network is called as Aloha Net. That network is called as Aloha Net. Okay, so so this is how the concept of classical Aloha works, and the first improvement over classical Aloha was slotted Aloha. Slotted Aloha, what it does in the sense, it introduced time slots. It introduced time slots, and it says that if any user want to communicate, they can communicate only at the beginning of a slot. They can communicate only at the beginning of the slot. It is not that they can communicate at any point of time. No, only at the beginning of the time slot they can communicate. So here, so that doesn't mean that there will not be any collision, but the probability of collision, it reduced. It reduced the probability of collision to a larger extent when compared with classical Aloha. Uh, because the throughput achieved by slotted Aloha is 36 percentage, whereas the throughput achieved with classical Aloha is 18 percentage. So it has doubled the throughput. It has doubled the throughput. So slotted aloha it is also used even in new mobile communication systems like UMTS. Okay, they rely on slotted aloha for initial connection setup. So that is done by a random access technique. Okay, so that is what about slotted aloha, and the next medium access technique that we have discussed is CSMA, carrier sense multiple access. So, what CSMA does in the sense, it is a next refinement on Aloha. So it says that first sends the carrier and access the carrier only if the carrier is free. Access the carrier only if the carrier is free. So that doesn't mean that there will not be any collision. Here also there will be a collision, but again the probability of collision is still reduced when compared to classical Aloha and slotted Aloha techniques. Here there may be a collision if two users are simultaneously sensing the channel, and if they sense the channel is free, and if they start transmitting the data simultaneously, then there will be collision. And also it cannot solve the problem of hidden terminal and exposed terminal. So with CSMA, the problems like hidden terminals and exposed terminal do exist, but this is a simple uh, uh, see a scheme which is used in most of the wireless networks. So there are several variations of CSMA exist. Like we have non-persistent CSMA. The non-persistent CSMA, it just checks the medium. If the medium is idle, then it starts sending the data immediately. If the medium is not idle, if the medium is not idle, then it will wait for a random amount of time before sensing the medium again. And it keeps repeating this pattern. So this is how non-persistent CSMA works. And there is a concept called P-persistent CSMA. With P-persistent CSMA, nodes sense the medium, but they only transmit with the probability of P if the medium is free. And they only transmit with the probability of P if the medium is free. And the stations differing to the next slot with the probability of 1 minus P. Okay, it will not always transmit. It will send with the probability of P, and it will differ for the next slot with the probability of 1 minus P. And one persistent CSMA, here in one persistent CSMA, all stations wishing to transmit access the medium at the same time as soon as it becomes idle. So this will cause many collisions if many stations wish to send, and they may block each other. Okay. To create some fairness for stations waiting for longer time, some backup algorithms were introduced. So one such example is CSMA with CA. CSMA with collision avoidance is one of the schemes in wireless LANs. It follows IEEE 802.11 standard, and in this scheme, sensing the carrier is combined with a back-off scheme to ensure that the station who is waiting for a longer period of time will get access to the medium at first. And then we have discussed certain reservation aloha protocols like DAMA and PRMA. So, so basically, DAMA is a reservation aloha protocol, and this is also called as an explicit reservation scheme. Here, there will be a reservation period followed by the transmission period, and during the reservation period, station can reserve future slots in the transmission period. The collision can happen during the reservation period, but there cannot be any collision during the actual transmission period. So there will be first reservation period, then transmission period, again reservation period, transmission period, like that. For every communication, the station should reserve the slot. And during the reservation phase, during reservation phase is also called as contention phase. During the reservation or the contention phase, the protocol follows aloha scheme. Okay. And during the communication phase, there will not be any collision. There may be collision during reservation scheme. So this technique is mostly used in satellite systems. And next we have discussed another reservation scheme which is called as PRMA, Packet Reservation Multiple Access. This is otherwise called as implicit reservation scheme. So this also uses mm, this is also mainly used in satellite communication. Here, here a certain number of time slots will form a frame, and the frame is repeated in time. And whichever the slot is free, for that the stations can compete. For that the stations can compete using slot and aloha technique. Okay, so that's it about this particular session, which is MAC medium access control. So let us stop here.